Okay, we are in 11.2. Section 11.2 is arithmetic sequences and series. Arithmetic sequences and series. Okay? So they define what they mean by an arithmetic sequence. An arithmetic sequence is a sequence. So the arithmetic sequence is a sequence. And this is on page 1017. Okay? So we're defining what we mean by an arithmetic sequence. Is a sequence of the form. They say A1 plus D, A1 plus 2D, okay? A1 plus 3D, A1 plus 4D, etc. This is a D. Okay. A1, next element is A1 plus D, next element is A1 plus 2D, A1 plus 3D, etc., etc., etc. Where A1 is the first term, A1 is the first term of the sequence. Okay? They say D is the difference from successive terms. D is AN plus 1 minus AN. So if this is A2, D would be A2 minus A1. It's the next term minus the previous term. If this was A3, D would be A3 minus A2. So it's the difference between any two successive terms, okay? And they say the nth term of the sequence, the nth term of the sequence is, they tell us the formula to write the nth term of the sequence, A sub n equals, we have A1 plus n minus 1 times D. And then finally, the sequence can be defined recursively. Sequence defined recursively is, they say A1 and then AN is going to be AN minus 1 plus D. And they say for n greater than or equal to 2. So there's our definition for an arithmetic sequence. So an arithmetic sequence is pretty simple. Whatever that first term is, you're going to add a fixed value to the first term to get the second term. Then add twice that fixed value to the third term to get to the first term to get the third term. Then add 3 times, so the next one would be A1 plus 3D, comma, dot, dot, dot. So you're just adding multiples of D each time, okay? So, with that in mind, example 1, which are arithmetic sequences. So are these arithmetic sequences? Is the question we want to know. So we're going to analyze these sequences and see if they're arithmetic sequences or not. So the first one they give us is 35, 25. That's the first element. Second element is 25. Third element is 15, 5, negative 5, dot, dot, dot. Okay? And they want to know, is this an arithmetic sequence? Well, if it is, then D would be A2 minus A1. 25 minus 35 equals negative 10. Or I can say D is A3 minus A2. A2. That would be 15 minus 25. That's negative 10. Or I could have said that D is A4 minus A3. Again, it can be the difference of any two successive terms. that would be 5 minus 15 equals negative 10. Or finally, I could have said D was a 5 minus a 4. That would be negative 5 minus 5. Okay? Negative 5 minus 5, which is still negative 10. So since the difference between any two successive terms is fixed, yes, this is arithmetic. Yes, it is an arithmetic sequence. Okay? That would be an example of an arithmetic sequence. The difference between two terms, D was negative 10. 35 minus 10 is 25. 25 minus 10 is, because all I got to do is add D to get from one term to the next. Since I found out that D was negative 10, add D to the first term. 35 plus negative 10 is 25. 25 plus negative 10 is 15. 15 plus negative 10 is 5. 5 plus negative 10 is negative 5. So that's an arithmetic sequence. Once you figure out D, all you got to do is add D to the term to get the next term in the list or in the sequence. B says 1, 5, 10. 1, 5, 10. 16, 23. Well, this one is not, because again, 23 minus 16 would be 7, but 16 minus 10, again, these should be the same. The difference between terms should be the same, any two successive terms. This would be only 6, so this is not arithmetic. The difference between terms is not a fixed number, so this is not arithmetic. Example 2. So pretty easy to tell. Example 2. They want us to write the first 5 terms of the arithmetic sequence. So A, write the first 5 terms of an arithmetic sequence. Okay? With first term negative 5, first term is negative 5, and common difference 4. So D is the common difference. So common difference is 4. Well, we saw here, when you have an arithmetic sequence, to go from one term to the next, all you do is add the common difference. Okay? The common difference was negative 10. 35 plus negative 10 is 25. 25 plus negative 10 is 15, so on and so forth. So the first term was negative 5. Negative 5 plus my common difference of 4. Negative 5 plus 4 is negative 1. Negative 1 plus 4 is 3. 3 plus 4 is 7. 7 plus 4 is 11. So there would be the first 5 terms. All you're doing is adding that common difference to each successive term. Okay? All right. B, part B of that example. Write a recursive formula. Write a recursive formula. They say to define the sequence. To define the sequence. Okay? Well, we said a minute ago that when we listed out the definition for a sequence, I said the sequence can be defined recursively as A1, comma, and they say AN equals AN minus 1 plus D. AN equals AN minus 1 plus D. Well, so I know what A1 is. A1 was negative 5. Negative 5. And then A2, well, no, I can just write AN now. So AN, okay, right, would be AN minus 1 plus D, okay? AN would be AN minus 1 plus D. So AN minus 1, D was 4. So there's my recursive formula. That came from that definition. That's how I'll write the formula recursively, okay? Just using that formula. And this is for n bigger than or equal to 2. I do need to put that. AN minus 1 plus 4. This one right here is only for n bigger than or equal to 2. You have to have that restriction, because A1 is defined to be -5. So this formula, this recursive formula, is only when the n is at least 2. Okay? Example 3. They give me the following. Example 3. They say a park ranger in Everglades National Park measures water level in one region of the park for a 5-day period. So this is water level over a 5-day period. Okay? So they're going to give us the day number, and they're going to give us the water level in inches. Water level, this is in inches, okay? For 5 days. 1, 2, 4, 5, okay? So days 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, those are the days. And the water level was 54.0. Second day, the water level was measured to be 53.2. On the third day, the water level was measured to be 52.4. On the fourth day, the water level was measured to be 51.6. On the fifth day, the water level was measured to be 50.8. So again, those are water levels in the park on those 5 respective days. Okay. Part A of the problem. In part A, they asked the following question. Does the water level follow an arithmetic progression? So is this arithmetic? I'm just going to say, is it arithmetic progression? As I go from one day to the next. So again, 53 minus 2 minus 54. Let's just do the first one. Minus 54. So again, day 2 minus day 1. 53.2 minus 54. That's negative 0.8. So D, if this is arithmetic, is negative 0.8. And the only question you have to ask yourself is, does that hold out? So take your calculators. 52.4 minus 53.2, that's still negative 0.8. 51.6 minus 52.4, that's negative 0.8. 50.8 minus 51, that's not negative 0.8. Oh, yeah, it is. 50.8 minus 51.6 is negative 0.8. So it's the same for everyone, so yes, this is arithmetic. Does it follow an arithmetic progression? Yes. B, write an expression for the nth term of the sequence. So write expression for nth term of sequence. Okay? Write an expression for the nth term of the sequence. Okay? Well, so we want to use that thing that right there. Okay? They say that AN, no. We're going to use that other one. AN equals, this was the formula I gave you when I wrote the definition for an arithmetic sequence. Right? AN equals A1 plus N minus 1 D. Okay? Well, I know what A1 is. A1 is 54. Okay? So AN would be 54 plus N minus 1. D, we just figured out, is negative 0.8. So I'm just going to write, well, I'm going to go write it like this, negative 0.8. Okay? So AN, let's figure it out a little bit. Let's clean it up. Negative 0.8 times N is minus 0.8 N. Negative 0.8 times negative 1 is plus 0.8. So AN becomes 54 plus 0.8 becomes 54.8 minus 0.8 N. That would be a formula to calculate the nth term. Okay? That would be a formula to calculate the nth term. Now, you didn't have to do all that. You could have stopped right here, but I went ahead and distributed. So either one of those is sufficient. Okay? Either one of those will give you the nth term. All right? Part C says, predict the water level on day 30. Predict water level on day 30. Okay. Well, we're going to use this thing right here. Where I hit C and N, I'm going to put a 30. And you can use this one or this one, it does not matter. So I'll have 54.8 minus 0.8 times N, but N is 30. If you do that in your calculator, you should get 30.8. So the water level should be 30.8 inches on day 30, or on day 5. Okay? All right. All righty. All right, that's that one. Example 4. Example 4 says, find the ninth term. Okay, of the arithmetic sequence. Okay. They say in which A1 equals -4. In which A1 equals -4 and A22 equals 60 and A22, they say equals 164. So the 22nd term is 164. Okay, the 22nd term is 164, and I know that A1 is 4. So recall that formula that said that AN equals A1 plus N minus 1D. Okay? Because I need to find A9. So if I use this to find A9, A9 would be A1 plus 9 minus 1D. Well, they gave me A1, but I don't know D. So to find A9, I'm going to need to find D. Okay? But to find D, they gave me A1 and A22. So I'm going to use this formula first, since I know the 22nd element, A22. So if N is 22, A22 is 164 equals A1. A1 is -4 plus, again, this is the 22nd term, so 22 minus 1, D. I can use this formula and these two things to substitute into here to find D first. Then once I find D, then I'll be able to use that same formula to find A9. But I've got to get the D first. So 164 equals -4 plus 21D. 22 minus 1 is 21. Add 4 to both sides. Then divide 168 by 21. You'll get D equals 8. Now that I know that D is 8, A9 is A1. A1 was -4 plus 9 minus 1, that's 8 times D, but D is 8. Okay? -4 plus 64, 8 times 8 is 64. A9 is 60. So A9 would be 60. The ninth term in that sequence would turn out to be 60. Okay? Example 5. Example 5 says, find the number of terms. Okay, this says find the number of terms. Find the number of terms. Okay? Of the finite arithmetic sequence. Of the finite arithmetic sequence. Okay? 7, 3, -1. 7, 3, -1, column. They say -5. Dot, 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 keeps going. But it is finite, but the last term is negative 113. So I've got a finite arithmetic sequence. I know what A1 is. A1 is 7. Okay? And I can figure out D because, again, the difference between successive terms, D would be 3 minus 7. Negative 4. And I could have done this minus this. Negative 1 minus a negative 3, or negative 1 minus 3 is negative 4. Negative 5 minus a negative 1 is negative 4. So D is negative 4, and A1 is 7. Okay? Now, I know what AN is. I know the last term is. I just don't know what the N is. But I do know that the last term in the sequence is negative 113. So we're going to use this same formula, right? AN equals A1 plus N minus 1D. And we're going to let N, we don't know N, so we need to find N. Okay? But I do know the last term. The last term, whatever that N is, that last term is negative 113. So I can put negative 113 here. Equals A1. I knew A1 was 7. Plus N minus 1D. I don't know N, so I got to leave that. D I know is negative 4. Okay? I knew the last term, I just don't know what the N is. The last term was negative 113, A1 is 7, N minus 1, I don't know N, leave that as it is, D is negative 4. I can use that to solve for N. 7 plus, negative 4 times N is minus 4N, and then negative 4 times negative 1 makes plus 4. Negative 113 equals, 7 plus 4 is 11 minus 4N. Subtract 11 on both sides. Anything you do to one side, you do to both. Negative 124 is negative 4N. Divide by negative 4. N turns out to be 31? 31. And you better get a positive number for N. N has to be positive. The number of terms in any sequence, finite or infinite, has to be a positive quantity. N turns out to be 31. Okay. All right. Example 6. Example 6. Make sure we're doing okay. Okay. Example 6. This one says, for an arithmetic sequence, arithmetic sequence, okay? A15 is 49. The 15th term is 49. The 15th term is 49. And they say the 27th term is 85. Okay, so they give us two terms in the sequence. They want us to find the 500th term. Find the 500th. 500th term would be A500, right? The 500th term would be A500. Okay, A to the 500. So tell me the 15th term is 49. The 27th term is 85. Find the 500th term. Well, we're still going to use this thing. So I know that AN equals A1 plus N minus 1D. So when N is 15, N is 15. Put a 15 where the N is. A15 would be A1 plus 15 minus 1, right? D. Well, A15 I know, so I can write 49 equals A1. I don't know A1. 15 minus 1 makes plus 14D. Okay? When N is 27, use the same thing. A27, well, they told what it is 85. So 85 equals A1. I don't know that still. Plus what? A27, so 27 minus 1 would be 26D. So I've got two equations right here. I've got 49 equals A1 plus 14D. And this second equation was 85 equals A1 plus 26D. Well, that's a system of two equations with two unknowns. That is a system of two equations with two unknowns. We learned how to solve those systems in Math 171 formally. You can either use the elimination method or you can use substitution method, okay? But you can solve this either way you want. So I'm gonna use, I don't know, elimination. So I'm gonna use substitution. I'm gonna solve 49 equals A1 plus 14D. I'm gonna solve that equation for A1. Well, it's very easy. All I do is subtract 14D. So A1 equals, I'll have 49 minus 14D. Now I'm going to take that value and substitute it into the second equation. So 85 equals A1, but I know what A1 is now. It's 49 minus 14D. So there's A1. 85 equals A1. 85 equals A1 plus 26D. So plus 26D. Now I've got an equation with one unknown I can solve. So 85 equals 49. Negative 14 plus 26D, these are like terms, I can combine them. Negative 14 plus 26 is plus 12D. Subtract 49 from both sides, and I'll get 36 equals 12D. D equals 2. 3. D will be equal to 3. All right? Well, since D equals 3, now I can take that value and substitute it in either one of these to find A1. So where I see a D, now I can put a 3. So 49 equals A1 plus 26D. Well, D is 3. So 49 equals A1 plus 3 times 26, 60, 78. Subtract 78 from both sides. Okay? You'll get negative 39 equals A1. Negative 39. No, something is wrong. Let's see. 30, 40, that's 60, 78. That's right. And that was, so 49 equals A1. Oh, I see what I did. My dyslexic self. It should have, I was using this equation. But I used the 26 instead of the 14. So that equation says 49 equals A1 plus 14. 14 times D. Sorry about that. 14 times D. So now 49 equals A1 plus 14 times D is 42. Subtract 42 from both sides. A equals 7. A1 equals 7. Okay. So now I've got A1 equals 7. Okay. And I know that D is 3. Well, they wanted the 500th term. So again, I'm using that same formula I keep using. All right. So A500 would be A1. We know what A1 is, it's 7. Plus N minus 1. 500 minus 1 is 499. Times D, but D is 3. Okay? Do that on your calculator. You'll get 1504. The 500th term would be 1504. Okay. All right. So not hard, just a little tedious. This was probably the hardest one we've done so far because we had to recall how to solve systems of equations. The only way we could solve this was to solve the system of equations because we had two unknowns. So you needed two equations. But we kind of see that we rely on this thing quite a bit. That formula for the nth term of a series, a sequence, we rely on that quite a bit. Well, now we want to talk about the nth partial sum. The nth partial sum of a sequence is, the way we're going to write it is S sub n. So what it means is it means A1 plus A2 plus A3 plus dot, dot, dot. Add them all up. And the way I'm going to write this is I'm going to use this summation symbol. You'll see this in your book. sum I equals 1, and this can be up to n of AI. Okay? If it's a finite sequence, this is finite because it says S of n. So whatever n you want, put there. So if n is 5. If the n is 5, you say A1 plus A2 plus A3 plus A. So let's write it. So if S5, the fifth partial sum, would be A1 plus A2 plus A3 plus A4 plus A5. And if I wanted to write it with summation notation, I'd say sum I equals 1 to 5 of AI. So there's my partial sum notation. That's what it means, and I can write it with this summation form. That's the summation symbol, that little symbol like that. That's called the summation symbol, okay? Well, so these are called partial sums, and I can write the nth partial sum. I can define whatever n I want to be. I can say S sub 3, first 3 terms, A1 plus A2 plus A3. I can say S sub 10, the first 10 terms, add them all up, okay? So, one nice thing about the partial sums, there's a formula for it, and this is going to be important. S of n, turns out we can find the actual sum of the series, or the partial sum, is going to be n over 2 times A1 plus AN. So if I know n, okay, they're going to tell me what n is. They're going to say S of 5. And I want to know what that fifth partial sum is. What happens if I add up the first 5 terms? Well, all I need to know is n, A1, and the last term, and I can figure that out with that formula. So with that in mind, example 7. Example 7. Find the sum of the first 50 terms. Find the sum of the first 50 terms of, they say, the sequence 2, 4, 6, 8, 10, 4, 6, 8, 10, keeps going forever. I want to find the sum of the first 50 terms of that sequence. Okay? I want to find the sum of the first 50 terms of that sequence. Okay? Well, I know it's arithmetic because each term differs by 2. To go from 2 to 4, I add 2. 4 to 6, I add 2. 6 to 8, I add 2. 8 to 10, I add 2. So that is definitely an arithmetic sequence, and I know that D is 2. Okay? So the first thing I notice, D is 2, A1 is 2. Okay? D is 2, and A1 is 2. Well, to use this formula, I want to find the 50 terms, and I'm not going to write down 50 numbers and add them up by hand. That's not smart. I've got a nice formula that'll show me how to find the 50th partial sum, okay? But to use it, I need to know n. I'll know n. They say the first 50, n is 50. So they told me n is going to be 50. I figured out that D is 2. I knew that A1 was 2. First term was 2. The only thing I don't know in this formula is A50, okay? A50. So we need to find A50. But again, AN is A1 plus n minus 1 D. Okay? That's that same formula we've been using. I say this finds to be pretty important. So A sub 50 would be A1. We know A1 is 2 plus n minus 1 D. 50 minus 1 is 49 D, but D is 2. So A50, 2 plus 98, the 50th term is 100. The 50th term is 100. So now S of 50, according to this formula, n is going to be 50, A1 is 2, A50 is 100. So n over 2, 50 over 2, A1 was 2, plus A50 is 100. Okay? So this is 25 times 102. 25 times 102